What if everything we thought we knew about Mars was just the surface, literally? In 1976, a grainy image taken by NASA's Viking 1 orbiter showed something no one expected, a massive weathered formation that looked eerily like a human face staring back from the Martian soil. At 1.5 kilometers wide and nearly 3 kilometers long, this feature, dubbed the Mars face, triggered a global frenzy. Was it just rocks and shadows, or the scar of a forgotten civilization? Suddenly, this dry, rust-red planet wasn't just a dusty neighbor. It became a mirror reflecting our deepest hopes and fears about life beyond Earth. But the face was only the beginning. Over the decades, as rovers like Curiosity beamed back thousands of high-resolution images, strange formations began piling up structures, resembling pyramids, eroded towers, and dunes that seem almost too symmetrical to be natural. Some scientists call it pareidolia, the human brain's tendency to find patterns in chaos, but others suggest we're missing something deeper. Could these anomalies point to an ancient Martian past, lost beneath centuries of wind radiation and sand? And what about Olympus Mons, the largest volcano in the entire solar system, standing 22 kilometers high and spanning 600 kilometers wide? On Earth, such a colossus would collapse under its own weight. But on Mars, with only a third of Earth's gravity and no tectonic plates, these impossible giants rise. Why did such violent geological activity shape Mars, only to vanish, leaving a silent, frozen desert? From ancient water channels to potential biosignatures, Mars is a planet of contradictions. The deeper we look, the more questions arise. Why does Mars, with its paper-thin atmosphere and deadly radiation, still show signs of once having rivers, lakes, and maybe even oceans? And if it did, what happened? Was it a slow freeze, a sudden collapse, or a planetary cataclysm we've yet to understand? More than just images, the data sent back from Mars is beginning to expose a silent history. One that may be far older, far more dramatic, and far more familiar than we imagined. As we prepare for the first crewed missions in the coming decades, one chilling thought lingers. What if we're not the first intelligent visitors to set eyes on the Martian horizon? What if we're just returning to a planet that once echoed with life? When NASA launched the Mars Science Laboratory mission in November 2011, few could have predicted just how revealing its flagship rover Curiosity would become. Weighing nearly 900 kilograms, the size of a compact car, and loaded with state-of-the-art instruments, Curiosity wasn't just built to roam. It was built to dig, drill scan, and decode Mars like never before. After its successful landing on August 6, 2012, Curiosity transmitted the first images of the Martian surface within hours. But what followed was far more valuable, a slow, systematic unveiling of a planet's past. With tools like X-ray spectrometers, atmospheric analyzers, and meteorological stations, Curiosity sent back detailed reports of Martian soil composition, radiation levels, mineral traces, and weather patterns. It wasn't just looking for scenery, it was hunting for habitability. And the results stunned researchers. In ancient rock samples, Curiosity detected clay minerals that form only in the presence of neutral water. Not acidic, not toxic, just water. The kind that on Earth would be suitable for life. Boiled down, the data implied one thing: Mars wasn't always a dead rock. It might have once been blue. This rewrote everything. If Mars once had stable bodies of water, a thicker atmosphere, and perhaps even a magnetosphere to shield it from cosmic radiation, it could have supported microbial life or more. But Curiosity didn't stop there. It sent back panoramic images of bizarre geological structures, rippling sand dunes, unlike any on Earth, towering buttes, and sedimentary layers that hinted at long-lost lakes and flowing rivers. Then came the deeper drills. Some boreholes revealed sulfur phosphorus, and carbon basic ingredients for life as we know it. Still, NASA remained cautious. Without organic molecules or unambiguous biosignatures, the evidence remained circumstantial. Yet even this restraint couldn't stop the questions from multiplying, especially when curiosity captured something else: images of Mars' two moons, Phobos and Deimos, both unusually shaped, pockmarked rocks, unlike Earth's smooth spherical moon. Their irregularity reignited theories of capture, not formation suggesting Mars may have once experienced catastrophic cosmic collisions or even inherited these moons from ancient interstellar debris. And amid all this, Olympus Mons loomed in the background, a dormant titan born during the Hesperian period between 3.7 and 2 billion years ago. Scientists traced its formation to massive lava flows, unchallenged by tectonic movement. Without shifting plates, to recycle Mars' crust volcanic material just piled up building mountains the size of nations. The implications were sobering. Without tectonics, Mars may never have developed the internal complexity that helped life flourish on Earth. Yet paradoxically, that same geological stillness preserved ancient features in pristine condition. No earthquakes, no subduction zones, just time, dust, and exposure. The result, a planet that's both frozen in time and brimming with historical clues. And as data trickled back over thousands of sols, Martian days, one reality became clear. This wasn't just a quest for science. It was a slow, unfolding detective story. The detective story took a surreal turn when NASA's high-resolution imaging orbiters revisited the region known as Cydonia Mensae, home of the infamous Mars face. Originally photographed by Viking 1. In 1956, the formation resembled a colossal human visage, complete with what appeared to be eyes, a nose, and a mouth. For decades, the image was dismissed as nothing more than a trick of light and shadow, pareidolia, the human brain projecting familiarity onto randomness. But the story refused to die. When later missions like Mars Global Surveyor and Mars Reconnaissance Orbiter captured sharper images in the early 2000s, the face appeared flatter, less defined. Skeptics declared the mystery resolved. But not everyone was convinced. Researchers pointed out that erosion over millions of years could easily wear down defining features. Others highlighted the oddly geometric structures nearby rock formations that bore uncanny resemblance to pyramids. One particular ridge, nicknamed the Inca City by NASA, showed patterns of parallel lines and sharp angles rarely seen in natural landscapes. Though the official stance was that these were natural formations, the name itself a misnomer, as the Inca never built pyramids, only fueled more intrigue. How could erosion produce not just one anthropomorphic shape, but a whole field of seemingly organized structures? Were these relics of intelligent design or coincidences amplified by our pattern-seeking minds? More curiously, why did NASA's tone subtly shift between amusement and dismissal rather than scientific neutrality? Critics argued that these anomalies deserved rigorous geological explanation, not vague labels. And while mainstream science leaned toward caution, the public imagination exploded. Films like Mission to Mars games, like Zach McCracken, and episodes of The X-Files began weaving the face on Mars into modern myth. It became less about the literal image and more about what it represented: a silent challenge from the universe itself, daring us to question the boundaries of what we call natural. Meanwhile, back on the surface, curiosity kept crawling forward. It captured selfies not for vanity, but to monitor wear and tear, especially on its wheels, which began showing damage after years of navigating razor-sharp rocks. These photos weren't just routine. They were survival data proof of how harsh the Martian environment really is. And yet, some of the landscapes looked eerily Earth-like: cracked clay, wind-sculpted dunes, even cliff faces that could be mistaken for Arizona or Utah, until you remember there's no wind howling through them, no insects chirping, no water trickling. Just silence. Deep planetary silence. That silence, however, might be hiding more than we realize. A growing number of scientists now consider the possibility that microbial life may still exist, perhaps beneath the surface, where subsurface lakes could remain shielded from radiation. Instruments aboard Curiosity, and later the Perseverance rover, are actively seeking methane spikes, a potential byproduct of biological activity. But Mars is stingy with its secrets. The methane detections have been inconsistent, appearing in some measurements and vanishing in others. These fluctuations continue to baffle experts. Are they seasonal, geological, biological? Or the result of instrumentation quirks? No one can say for sure. But one pattern is undeniable. Every time we peel back a layer of Mars, more complexity reveals itself. Not just geologically, but symbolically. Mars has become more than a research target. It's a planetary Rorschach test. What we see there often says more about us than it does about the planet. Some see ruins, others see erosion. Some see a future home, others see a cosmic warning. But beneath the debates, one fact remains. We've only explored a sliver of Mars, and that sliver already rivals our most imaginative fictions. The deeper we go, the louder the silence becomes, and silence in science often signals something worth listening to. As we approach a future where human boots may finally touch the Martian surface, the planet's quiet enigma is beginning to echo louder in the chambers of science and politics alike. August 2048, marked as the next optimal window for a crewed Mars. Flyby looms large on the calendar of interplanetary ambition. But long before that, SpaceX founder Elon Musk is racing the clock, vowing to put humans on Mars within this decade, sidestepping the state-funded red tape with private funding, rapid prototyping, and a revolutionary vision. Whether these goals are feasible or fantasy remains contested. Critics argue that Mars is not just distant, it's hostile. With a surface pressure less than 1% of Earth's deadly radiation and average temperatures colder than Antarctica, Mars would kill unprotected humans in minutes. Even with advanced suits and habitats, long-term exposure raises chilling questions. How will we grow? Food, produce oxygen, recycle water, and what happens to the human mind under years of Martian isolation? Still, the draw is undeniable. A successful manned Mars mission would be a seismic moment in human history, one rivaling the moon landing, only this time 56 million kilometers from home. For many, it's not about survival. It's about expansion, legacy, even species insurance. But there's another less spoken motivation: the search for origin. A leading theory now suggests that life, microbial, simple but alive, might have first emerged not on Earth, but on Mars, during a period when the red planet had water, warmth, and organic chemistry. If true, then Earth's biosphere may have been seeded by Martian meteorites billions of years ago. In this view, a Mars landing becomes more than exploration, it becomes a homecoming. Already missions are zeroing in on biosignatures, subtle chemical fingerprints of past life, including methane water, vapor residues, and isotopic anomalies. Instruments designed to detect them are growing more sensitive, more specific. And yet there remains the nagging paradox: the closer we get to an answer, the more elusive it becomes. Is it possible that we're looking in the wrong places or asking the wrong questions? Perhaps life on Mars isn't a past event, but a current one hidden beneath layers of ice, rock, and time. Or perhaps we're searching for biology too similar to Earth's, overlooking alien chemistries entirely. And if we do find life or evidence that it once existed, what then? Would it unite humanity under a shared sense of wonder? Or would it fracture us even further, politicized like everything else in our era? In the silence of Mars, there is no response, only data sandstone and mystery. But every image, every anomaly, every mission brings us closer to an answer or a new question. And so we ask you, if proof of ancient Martian life was discovered tomorrow, would it change what you believe about Earth, about history, about yourself?